hey, this video is for honors students specifically this year. We're doing this YouTube style because we have to be at a curriculum planning meeting. We chose to do Dalton's Law today because this one isn't that bad of a gas law. Literally, all it is just addition. Okay. One of the biggest problems that people have with Dalton's Law is first that they just don't read the question, so they don't know what they're looking for, and so they'll do the math wrong. And the other big mistake people make is that they forget that when you're adding things together, you have to be in the same unit. So sometimes we'll trick you and we'll say, this partial pressure's in kilopascals, this one's in kilopascals, and this one's in atmospheres. And instead of converting to kilopascals, people will forget that, and then they end up getting it wrong. I'll talk about this in a second, but just want to let you know those are the two mistakes you're going to make, so just be careful. Okay, so Dalton's Law of Partial Pressures, all it's saying is, hey, the total pressure of a sample of a mixture of gas is equal to the partial pressure exerted from each of the individual types of gas. Okay, so for example, the total pressure of this mixture is equal to the pressure that oxygen exerts, plus the pressure that neon exerts, plus the pressure that helium exerts. And altogether, those three components, they make up that total pressure. So all it is addition. Okay, something you might need to remember, you might want to write this at the top of your paper somewhere to remind yourself. 1 atmosphere is equal to 101.3 kilopascals, which is equal to 760 millimeters of mercury. And the problem I'm about to do with you, you aren't going to have to use those guys. But I believe it's number 3. Be careful. I'm pretty sure I remember one of them is in kPa while the rest is in like atmospheres. So make sure that you convert this guy to atmospheres before you start adding them all together. And again, use this. Go to my YouTube video that teaches you converting pressures, or go back to your notes/homework page that taught you how to convert pressure. All it is just a one-step Stoic problem. So we're going to be doing number 2 on your Dalton's Law page in your packet. Okay, so just go ahead and read and identify what we're dealing with here. It says a container holds oxygen, hydrogen, helium, and carbon dioxide gases. Okay, the total pressure of the gases in the container is 225 kilopascals. And then the partial pressures are as followed. The partial pressure of oxygen is that. The partial pressure of hydrogen is that. The partial pressure of helium is that. And now it's asking for the partial pressure of CO2. Okay, so my givens here, we have P total is equal to 225 kilopascals. P of oxygen is 56.8 kilopascals. P of hydrogen is equal to 15.9 kPa. And P of helium is equal to 86.1 kPa. My unknown, they asked for the pressure of CO2. And we know that we're doing Dalton's Law, so that's pressure total equals the partial pressures of everybody added up together. So when we substitute this, we're going to say, okay, P total was 225. I'm going to double check and make sure that everybody's in the same unit. Yes, they are. So I don't need to really worry about that right now. If one of them would have been different, I would have done a quick conversion to get to the same unit as everybody else. But in this case, I'm not dealing with it. So equals 56.8 plus, who else was there? 15.9 plus 86.1 plus my partial pressure of CO2. So in my calculator, I'm going to go ahead and add these guys all together to kind of simplify this. So it's going to say 225 is equal to, and I'm going to say 56.8 plus 15.9 plus 86.1. That ends up equaling 158.8 plus my PCO2. And now I do the opposite of what I had on that side. I can't remember what the word is. Operation? Opposite operation? Inverse operation? So that I can get my PCO2 all alone. And so in my calculator, I'm going to say 225 minus 158.8. That equals 66.2 kilopascals.